All right, so today we have my friend Mars Lan, co-founder and CTO at Metaphor, which you can find at metaphor.io. Tagline is the data catalog for every team. Metaphor is the social platform for data powered by AI. We're built into Slack, MS Teams, and a Chrome extension for instant answers and streamlined collaboration regardless of technical expertise. And full disclosure, I'm an advisor to Metaphor, although we won't talk about Metaphor, the product, much in this podcast. This is actually focus on open source security and maybe something towards the end about knowledge graphs. So Mars, welcome to the podcast.
A pleasure to be here, and thanks for having me.
All right, so Mars, by context, I'm going to link this article to the article he wrote in the episode notes. The article is titled, "Is Open Source Software More Secure?" And then subtitle is, "Despite the belief that open source software is safer with many eyes on it, recent hacks prove that hidden vulnerabilities can still slip through, risking major disaster." So, first question, what inspired you to investigate security vulnerabilities? I guess in specific open source projects, Data Hub and open metadata. So what, I guess you work in the space, but did you consciously go do a deep dive into these two projects?
So I always have an interest in security, but I'm not a security person per se, right? Security is never my expertise, so to speak. But I'm very much into security, and you know, there's probably enough in the news that that people are aware of the severe consequences when you're not paying attention to security per se. So we've been doing a lot of security related work. By because of the sort of the clientele that we work with. So Metaphor, like you mentioned, is a data catalog, and it is working with pretty much any company that wants to democratize the data, want to push for data enablement, or even want to just to get a good grip of their data, improving their data governance. And of all the customers that we work with, there tend to be companies that are in sort of financial industry, financial services market, and insurance companies, and and more recently, medical related, healthcare related companies as well. So these companies have always, traditionally have always been very security conscientious. So they obviously security is non-negotiable in those cases, and because of that, they certainly put a huge scrutiny on us as well, making sure that if they're buying Metaphor, they're buying a secure software, right? So because of that, we've been paying a lot of attention to this particular area, which is to do with third-party or software supply chain security. We, like most software companies out there, we rely heavily on open source, whether it's library, framework, and sometimes, even an entire tool, right? That is not uncommon. And as we sort of explore this, security related issue, we realize that this is a very difficult problem, right? Because you imagine that you use some sort of third-party software, which use another third-party software, which use another third-party software. The chain goes very, very long. And somewhere in there, if there's a known vulnerability, your software get impacted, right? Whether you directly use that dependency or not, you are impacted as well.
And by the way, our listeners who work in AI and machine learning are quite familiar with this. In fact, I wrote a post. Basically, anytime you pip install anything in Python, it'll install 20 things, maybe even uninstall versions of libraries you use to make it compatible with that library. So it is quite a extensive problem in machine learning in particular.
Yes, I think Python is well known for its dependency hell, so to speak. we use Python obviously, but we also use TypeScript, right? So the whole npm ecosystem is even worse. There's a joke, and it's actually not a joke, right? There's a library out there, npm that do one thing, which is padding, adjusting your padding on the left or something like that. It's that kind of one-line library, right? But it get downloaded many times and used by many libraries. So I think people are getting very used to the idea, and for a good reason, right? And you don't want to reinvent wheel, right? But for people are getting very used to the idea of, hey, whenever I'm doing something that I feel like it's not my core business logic, there ought to be someone who's done a library like that and better tested and whatnot, better used by a lot of people. Why reinvent the wheel? Why not just use those libraries, right? And because of that, you get into this state where no one's really writing the entire program on their own. Right? They're always depending on a lot of open source libraries out there. Come back to your original question, right? What sort of sparked the interest initially is because we're doing all these auditing, right, either by our customers or ourselves, looking at this particular issue with open source security, right? We realize that there are good tools out there, and then luckily we're using GitHub, for example. GitHub has a tool called Dependabot. I think most your listener will know that very well, which does this excellent job of scanning all your security and all your dependency and your transitive dependency and your transitive dependency to map against the known vulnerability out there, right? And then flag them and tell you that, hey, look, and on a good day, it will even help you create a PI and help you fix it, right? Sometimes it's more complicated than that, so most of the time it will give up. But when you're lucky, it will even be able to create a PR for you, and then you can easily merge that change. So we obviously run that all the time against all our software, right? Even though our software, the core of our software is proprietary, but like I said, we use a lot of open source libraries as well. So we want to make sure all those libraries are secure. Then we also have open source stuff. All our connectors are open source, so our customers can take them and audit them to their heart's content, right? Same story there, right? All that obviously have to be checked, strictly checked. And even more so than our core product, because those connectors, a lot of customers will run them in their environment, in their VPC and whatnot, right? This is the so-called data plane, right? Versus control plane. That's the data plane where they run in their environment. They obviously want to make sure there's nothing, shady going on with those library, right? There's no vulnerability in those library. They don't want to expose their, war garden to the entire world through that.
I see. So then you run the Dependabot, you realize certain libraries you depend on may have problems. You, I guess, file issues, and then they don't get, as I understand it, maybe they don't get resolved in a timely manner.
So we do try to fix, any dependency of ours to the latest version if possible that doesn't have vulnerability, right? And obviously, if there's an issue that's not resolved, we have to go up to the maintainer of the library and tell them, hey, this is the issue. Can you fix it? Or even do our own local patch sometimes, right, to get rid of those vulnerability. But the article that I put out recently that talks about two particular projects. These are not projects that we depend on in any way or shape or form, right? We don't have any dependency on them. So one is Data Hub and the other one is Open Metadata. And the reason why I picked those two is, for the listener who don't know the history of it, Data Hub is a project that I and the team I led at LinkedIn created in open source. We're not affiliated with that project anymore at this point, but we've very familiar with the project. Right? Yeah. And then Open Metadata is another project that's sort of in the same field, right? And then also, full disclaimer, right? Both projects are in the same field as Metaphor, right? So, to some extent, we are competitor, right? I don't think there's anything.
So this is, it's not that you're picking on these projects, it's just you're familiar with it and you're trying to understand the security situation more broadly in open source, and you just two projects that you're familiar with.
That's correct. And like I said, these are the only two open source projects. Actually, there's Amundsen, the third one, which is semi-dead at this point. So these are the two active project, open source project in the field, and then one particular one we're very, very familiar with. So that's why we picked these ones. And then also because of the nature of the product, right? Any data catalog or any metadata platform, if you will, need to connect to multiple systems, right? In order to grab the metadata from everywhere. So by that very nature, it will in and of itself have to depend on many other libraries out there, right? If you want to talk to Snowflake, you need to bring in the Snowflake library. If you want to talk to Databricks, you need to bring in the Databricks library, right? So you have this natural tendency of depending on hundreds of different kind of libraries in this particular area. And then that's why this problem is particularly bad for, a data catalog, right? Because, you just, whether you like it or not, you will have to go down that path of depending on many, many different third-party libraries. So sorry, coming back to it. So the sort of motivation behind the blog post was that we were doing this ourselves and we realized how difficult it is. And then we thought, okay, well, let's take a look at open source and see if open source is doing any better, right? Because obviously we're a proprietary company. Take a look at open source, right? Because one of the main things that people talk up about open source is, because of the code availability, because it's open source, anyone can take a look at it. So of course it's going to be more secure, right? And that's by definition, right? Compared to a closed source system where no one can look at it other than a handful of engineers.
So-called many eyes, right? So.
Exactly, right? Which, I think it's pretty well proven throughout the year, right? So that's my initial perception was like, okay, and if you
that's Mars, that's more like let's see, how should I put this? That's more of like heuristic, because basically, yes, you can put many eyes, but it also assumes that the many eyes are active.
Right? You're pointing on a very good point there, right? So we didn't think about this before we went down this path and doing the sort of the mini investigation of ours, right? Our assumption was twofold. First of all, many people are using the project, many people are looking at it. Theoretically, if there's any vulnerability, someone's going to up an arm, right, about it. Point number two is there's also reputation risk associated with this, right? Because your software is open source, and then both software, right? Let's also make it clear, right? Full disclaimer: both projects have companies behind them, right? Mm-hmm. Real companies trying to make business out of them.
Right.
So you will think that there's reputation risk associated with that as well, right? Now if your business is based on open source and your open source project is out there, everybody's looking at it, you better keep your house clean, so to speak, right? If your guests have to come to your house, you want to make sure everything's clean at that point.
By the way, the same thing is true for proprietary software in the following sense, right? So if there's a known security bug in either open source or proprietary software, if it's known that this is an open issue, then people will want to see how timely this issue gets resolved, right? So, but in the case of open source, it's a lot more likely that it's out in the open. If someone,
it's more visible, right?
It's more visible, right? Yeah.
Exactly. No, absolutely. Sorry. So that's our assumption. Initially, we thought, we'll take a look at how they're doing it, and we expect the result to be clean, right? Coming back, so to speak, right? Because, like I said, there's many eye theory out there, right? So, but there's a funny thing about open source, and then I think you sort of alluded to that as well, right? It sort of creates this false sense of security, right? Like you said, I mean, because many people are using it, because many people are looking at it, it must be safe, right? And then because most people have this perception, then very few people actually end up paying attention to this part, right? Because everybody assumes everybody else is doing their job.
It's not even correlated. What you just said is not even correlated to the level of activity in the ecosystem. So in other words, the ecosystem can be active in that people are adding features, starring the project, but if no one is actually fixing security issues, that's a completely separate thing, right?
Right. And to be honest, right, if you ask engineer, would they rather be fixing security issue or building new
features.
thing, they will always
Yeah, exactly.
always use the new feature, right? If there's no CISO in the company, I bet no one will actually push the engineer to work hard on security
All right. So
side.
then,
Yeah.
what are the key findings?
So let me preface that for a little bit more. I think there's also another thing which is sort of this whole mini I theory also somewhat fall apart in this particular case, right? Like I mentioned, GitHub provides this great service called Dependabot, which will scan your repository and then will report all the vulnerability, right? And for a good reason. It only does it and expose that to the repository owners, right? These information are not made public, quote unquote, automatically. And then it's up to the repository owner to decide what they're going to do with these reporting, and then they can even put out kind of a public advisory notice, right? After they fix it, they can say, oh, everybody please move to version 2 because version 1 had this vulnerability, right? They can do that. You can choose when to do that, how to do that, and all of that. So a lot of people, when they clone the repository, right? Open source, when they clone the repository, by default, Dependabot is not enabled, right? So when they clone it, they look at it and say, "Oh, no security issue, great." Right? And the reality is, Dependabot wasn't enabled. It doesn't inherit that setting from the parent repository, right? But you can easily enable it, and as soon as you enable it, you can see all the vulnerability that the maintainer is supposed to be seeing at the same time as well. Right?
So if you're a nefarious actor, in other words, you're looking for 0 days or exploits, obviously you would do this too, right? So pick a popular library in the AI or ML ecosystem, clone it, enable Dependabot, and then there you go, right? So
you're exactly right. Right. To some extent, it actually exposes your open source project to even more risk than proprietary, right? Because when it's proprietary, you cannot see, right? So the best you can do is you try every single vulnerability that you know and see which one works, right? And then a lot of time you have limited surface area because you only see, whatever port is open and try it that way, right? But in open source, it's a double whammy. First of all, you get to see the source code, so you can find out what vulnerability is, right? But most people obviously don't have the time to read through millions of lines of code to find out where the vulnerability is, right? But Dependabot does an excellent job of surfacing all that vulnerability to a nefarious player, right? And then if the maintainer is not doing the job of closing those things, it actually basically give a laundry list to the hacker and say, well, now you know all my vulnerabilities. Please go and attack me that way.
And by the way,
So-
Mars, you can imagine a future where someone can fine-tune a model, foundation model, specifically for finding vulnerabilities, right?
Oh yeah, I mean this thing is very automatable, right? I would not be surprised if some
Already
active
has done this.
groups out there is already doing that, right?
Right.
I mean it's not rocket science, right? It's very easy to do. So that's exactly what I did, right? Like I said, I cloned the repository, turn on Dependabot, and lo and behold, there was 30, 40, vulnerability that's open in both,
Projects.
I think one is like 20 something, the other one 30 something, right? And these are high and medium severity, right? Not critical, granted, right? Critical ones have been fixes, but higher and medium severity is not to be sneezed at either, right? So
now, just to clarify, did you clone the most recent active versions of the project?
yeah, when you clone, you always clone from head, right? And then I did run the Dependabot against head, so to speak. So that was whatever latest at that moment. And then these are open issue that had not been addressed. And some of them have been open. If you look at the history of the vulnerability, and then when it was first, made public, some of them go back in years, right? It's not like, okay, it only happened yesterday. Of course, it hasn't been fixed yet, right? This is like some of them have been around for years without being addressed.
Years, meaning you were still involved in the project when some of these were.
Potentially, I mean, I haven't. We were not able to work on the project for the past nearly 4 years. So
Yeah,
yes,
yeah.
anything before that, I take partial responsibility for that too.
Yeah. So then you pick up this laundry list from both projects. So then what did you do next? Did you file issues with both projects?
So in the sort of security world, right, the so-called best practice, or it's called responsible disclosure, right? What you do is you go and talk to the project owner and say, "Oh, I discovered this new vulnerability."
Before you make it public, right?
Before you make it public, right? That's the responsible way of doing it. I think in this case it doesn't quite apply, right? Because these vulnerabilities is actually out in the open. The sort of responsible disclosure are generally, hackers who would discover new vulnerability that have not been made public yet. They obviously want to claim that.
By the way, for our listeners, there's an excellent book by I forget her name, Nicole Perlmott, about 0 days. And so what happens now is actually they don't disclose. They actually either sell it to the company or sell it in the black market, right?
Well, some company has this bounty program, right, where they encourage hacker to essentially submit these security bugs to them, right?
So in your case, what you did is so straightforward that it's not like anyone can do what you did in terms of finding this list.
Exactly. I'm not a hacker. I'm not a security expert.
Right.
I did not discover this myself per se. And these are quote unquote open, out in the open for years. Once again, like I reiterate, right? So going through the responsible route doesn't seem to make sense, so to speak, because like I said, those are dedicated for these things, right? So what I end up doing is we wrote a blog post about it, try to bring awareness to people, knowing that, hey, look, this is a situation, right? And you might argue, why blog post, right? Why go public with this sort of thing, right? If this, if it's open already, right? That's the exact point of that blog post, right? I can almost guarantee you, if I did not write that blog post, these things will still be there today. Mm-hmm. These things will still be there 10 years from now, because it has been there for so many years, right? With no one paying attention to it. And it's completely out in the open. It's not a secret, right? Just people are not looking at it. So the blog post, the main purpose of the blog post is to bring attention to the people, like, hey, look, here's some real problem, right? And then it's out in the open. You're just not looking at it, right? And no one's looking at it. No one's, the maintainer doesn't care about it. Whoever uses it doesn't care about it, right? No one care about it, but they are there. Who will care about it? Only the hackers and the security expert care about it, right? No one else will care about it if I do not bring this up, surface this up to the public. Right?
So what what you're going to tell us next is that there's a fairy tale ending. You brought up the issues, and then lo and behold, they all got fixed, right?
That's the hope, right? I think I would imagine I would imagine this should do the trick, right? If nothing else can do the trick, this should do the trick, so to speak. It was actually a complicated story, right, so to speak. So first of all, I put out the blog post, right, and then tag the companies behind these projects, so they don't know the thing is out there, right? No reaction, no response, no reach out, nothing for a whole week. Then I think, okay, maybe people missed it and whatever, right? That could be that.
But also the route you took is something they could easily replicate anyway. Right?
Mm-hmm.
So, yeah.
Yeah, I would think there should be some urgency around behind this whole thing, right? Once they see it, but it wasn't. So a week after, I created.
Wait. So then, I guess if I were the open source project, right? So let's say I'm the open source project. You wrote this post. The immediate thing I think I would do would be, okay, I'll write a post myself and say, okay, we acknowledge this, we're on it. That's it.
Yeah. You would think that would be the responsible thing to do, right? Yeah. Nothing at all, no acknowledgement of this thing, no announcement to their respective community either, right? Because I think that would be the responsible thing to do, is tell your community, hey, look, yes, you guys probably saw this, we are on top of it. We apologize, right? We overlooked this for years, but thanks for bringing this up. Now you bring this to our attention, we'll quickly go and fix it, right? But everybody, please rest assured, we're on top of this. Nothing at all coming from that.
So Marco, I guess I'll do the kind of the counter argument in the following sense, right? So you publish your post. I look at it. I'm one of the project leaders. I replicate what you did. Okay, lo and behold, yep, Mars's list looks correct. We can acknowledge it in our post on our own and tell our community that we're on it. But then upon further inspection, since Mars is no longer involved or doesn't really know these projects well, these are really minor things. So therefore, I'm not going to, I'm not gonna do anything publicly or kind of panic my user base, right?
So this is one of the reasons why we chose project that we're familiar with, right? You're absolutely right. I think you cannot, blanketly say, label every single vulnerability as critical, severe, or whatever, or impacting, have real impact and whatnot, right? The detail, there's a lot of details around it, right? And absolutely, right? The 30 also vulnerability that I found in those, some of them belong to dev tool, and you see this a lot, right? The developer tool, right? Compilers, code generator, your CI/CD tool, whatever, right? So some of these themselves will have vulnerability, and then of course, the severity of that or the actual impact of it, or someone being able to exploit that particular part is much, much lower compared to your main product, so to speak. But the majority of those, especially the high and the medium vulnerability, have a direct impact on the product itself. So these are not something to basically sweep it under the rug and say, oh, it's not a big deal, right? It's not something that doesn't impact anything, right? No, it does actually impact the product, right? You can always argue how practical is it for someone to really leverage that and hack into your system and all that, right? Of course, once again, not every vulnerability are the same, right? But the fact, once again, like I said, someone knowing this thing exists, right, and then know exactly how to exploit it is actually very dangerous if you think about it, right? If it just fall into the wrong person's hand, you may not be the immediate impact, right? But most of the attacks, security attack, basically go through this sort of land and expand motion, right? They enter, some secure networks through some weak point, and then in there they start expanding all these things. So if you remember the recent ones, right? Snowflake, Okta, right? These like big headline security breach, right? How did people get in from there? They didn't get in from the main Snowflake product. They didn't get in from the main Okta product, right? Because those are pretty well secured, right? They went in through some customer service software. They went in through some whatever internal use tools, right? That's how they got in the first place. Right, and then that's actually quite dangerous if you think about it, right? Even if you have some tool that is internal that only runs in your network, supposedly no one is able to access it outside of your own network, right? Guess what? As soon as the hacker get in, as soon as they know there's some software that you have there that's vulnerable, that can be the next jump point. Right? They can go there and start leveraging that.
So then now we're about 5 weeks after you published the post. Where are we with the two lists?
So like I mentioned, a week after I published the blog post, I didn't hear anything from either project and either companies. So I decided, hey, maybe it wasn't clear enough. Maybe it missed their radar or whatever. So I went into their GitHub repository, each open up an actual issue there, right? Now it's actually reporting officially at that point, I guess, right?
So
it's clear as day.
You took both lists and then you...
Yes, I put it right there inside the repository. Now it should be clear enough that there's an issue right there that needs to be addressed. I also posted on their Slack, respective Slack channel, right? And I got very different response. Once again, on the open metadata side, it was initially some sort of denial, right? Trying to downplay this and say this is not important. These are like whatever bugs and whatever. There's some back and forth. Eventually, they acknowledge that this is actual problem. They're gonna fix it as quickly as possible.
Back and forth with you, or back and forth with their community?
Back and forth with me. You can see the whole communication within the GitHub issue. Right? You can probably link that to your
and then their community
well,
their community presumably is seeing this back and forth, right? So.
Yeah, you would think so, right? You would think so.
Yeah.
And then on the other hand, Data Hub is complete cricket, right? There's no response to my GitHub issue, no response to my Slack message, nothing at all. It's just complete quietness, right? And at that point, I basically give up, right? What can I do, right? What else can I do, I guess?
So then at this point, what percentage of the issues remain unresolved?
So 5 weeks later, from the initial blog post, Open Metadata did a good job. Like I said, after my persistent back and forth with them, they managed to fix most of the bugs, right? I think now there's only 2, 3, whatever left open, right? Of course, new vulnerability will keep opening and all that, but the point is you're gonna address them as soon as they open, right? Data Hub pretty much stayed the same. In fact, I think when I first wrote the blog post,
So
it was 16.
the list is still the list.
The list is pretty much the same. Not much change there, right? I think, and then there's a couple of medium issues got closed, but there's actually more high impact issue now than where it was before my blog post, right? So now it's like 18 high severity issue versus 16 when I originally wrote the blog post. Once again, still no response from the team behind it, and it doesn't seem like they're actively fixing these either. So that's kind of the current status. Yeah.
So then, of course, your blog post title is open source software more secure. Obviously, in this case, you use tools to kind of identify issues in open source projects, but as you correctly point out, proprietary software may have the same problems, but since you cannot apply the tools you apply to proprietary software, you're not aware that that some of this proprietary software doesn't have the same kind of problems that dependabot would surface, right? So in other words, I guess we don't know the answer to the question you posed in the title of your post, right? So which is open source software more secure? It's unclear. The advantage of open source software, I guess, is you can apply tools like Dependabot. You can see what's wrong. And so then you can put pressure on the companies. On the proprietary software side, you cannot apply tools like Dependabot. So there's less. So on the one hand, open source, you're not flying blind, but you're dependent on the responsiveness of the community. On the proprietary software side, you might be flying blind, and so you don't know. So is that
I think you're absolutely right? I think the visibility is a helping factor. I don't think I'm trying to deny that at all, right? I think that point is completely valid. And some may even argue, right, well, today you're able to write this blog post because of visibility, right? If there's no visibility, you cannot even write this blog post in the first place. I think that's all fair point. I don't disagree to any of those points, right? But I think the main point behind this whole exercise is to show people that it's not a given thing. Security is not something that you just get magically if you open source your project, right? And if the team decided to not work on it, it will still be as insecure as a proprietary software or any software out there, right? Ultimately, it still depends on people, depends on team trying to put security above everything else, right? And some of the most secure software out there that's used by huge amount of people on a daily basis is all written proprietary. Right? If you think about it, all the social networks proprietary, all the hyperscale cloud, the management software and whatnot, the hypervisor, all these are proprietary. None of them is open source, right? Sure, there's Linux server running as here and there. That's for sure. That's given, right? But then the real crust of it, they're all proprietary. Right? Why don't they open source it, right? If they want to be secure, right? The reason behind that is obviously there's commercial interest and all that. That's why they don't open source it. But they are secure because they put in a lot of investment, right? They put that front and center for these teams, and then that's the focus of the team. That's why they deliver secure software, whether it's open source or closed source in this case.
And they may be.
So I think that's yeah.
Some of the most popular software and secure software might historically be open source, but they've since been forked, and who knows? all the kind of extra security that the companies have applied, right?
Potentially, yeah. A lot of even in the OS space, I think there's many forks that happened in the past, right, where the company just take the software and
By the way,
proprietarize and
Mars,
most.
in the AI LLM space, right? So there's really no open source model. There's open weights models,
Yeah.
and so then the discussion is more around. It's really not. I guess people, I mean, there's some people who say we want open source in the sense of open source software. So you would have to show us your training data, your
Mm,
setup for how you train the model and all that. But that's not, I don't think that's ever going to happen, right? So the best scenario right now is open weights. So then the distinction is between open weights and then the proprietary endpoints like OpenAI, Claude, and Gemini.
mm,
But
mm,
then as best I can tell, the only reason why a lot of people are really excited about the open weights model is that they can run with it, they can fine tune it, they can put it on their on premise, right? So and all of this, and so it's more of a control thing. It's not really. No one is talking about open weights being more explainable or more secure or anything like that.
mm.
Yeah,
Yeah, I mean, if you think about it, why did Meta open source their weight in the first place, right? I mean, I
well,
think to them they come to the realization.
isn't it marketing?
Certainly, there's a big part of marketing around it, but I think the most important part they come to the realization of it is it's just numbers, right? Literally, it's just numbers. What make it magical is the training data, right?
Yeah, yeah, and
And then
also
as long, yeah,
the ecosystem. They can build an ecosystem because people are
yeah.
more likely to use their model because
Oh yeah,
some
oh yeah,
level of openness, right?
yeah. I think there's a lot of sort of benefits around brandings and around all these sort of ecosystem. There's no doubt about it. But yeah, I think it is difficult to say whether this is a sustainable thing, right? I think as let's say, I mean, Meta is open sourcing their way right now today because they are not using it to really sort of they're using it internally right now, but it's not their core business, so to speak, right? Whereas OpenAI, that's their bread and butter. That's the only thing that they sell, right? So of course they're not gonna give it out for free. That just completely destroy the business model. But let's say if one day Meta completely pivot into AI company that's selling AI products and whatnot, they might stop doing this, right? Or maybe they will keep releasing a crippled version
Yeah.
or inferior version and keep the best version in house. Yeah.
Yeah. So then, I guess just to kind of close the loop on this part of the podcast, open source software, um, it's not clear cut that it's more secure. Yeah, I mean, you have more control in the sense of you can run all these tests. You can look at the source code, you can run tests. Proprietary software, you can't see the source code, and you may not be able to run all of the kind of depend upon kind of tests.
Mm-hmm.
Um, so there's no slam dunk answer, which is the point of your post, really, right? So
Exactly.
because
Yeah. It's up to the
reputationally, people just think it's open source, it must be secure because there's many eyes, right? So
yeah. I think ultimately it's still the same thing. It boils down to the team, right? If the team cares about security, they'll make it secure. If the team doesn't care about security, it will not be secure by virtue of open sourcing it. So.
all right, I want to spend a few minutes because I recently found out that you folks at Metaphor use graphs and knowledge graphs as part of your product. So I guess very quickly, Mars, before we go into the graphs and how you build it and why it's useful, very quickly describe to our listeners uh, what the Metaphor product is and how is it used?
Right. So at the outside, we talk about how it's a data catalog, right? That's the type of product. But if you really want to sort of double click into it, right? The real problem, Metaphor or any other vendors in the same field trying to solve is, understandability and trust in data, right? And this is something that we observed very well back at LinkedIn, where it was where there's a great culture of data democratization, right? Data enablement. Literally thousands of data scientists and analysts that are essentially playing with data day in, day out, trying to derive insight, trying to turn things into actionable actionable things from business side and whatnot.
So in practical terms, what does that mean? Let's say I'm an analyst or data scientist. What am I getting?
So one of the biggest problems that analysts and data science people are facing especially inside a big company, is not about I don't have enough data. It was actually almost quite the opposite. It's like, I have a lot of data. I know we have a lot of data as a company, right? But where are the data, right? Where can I find them? And then if they found something, can I trust this? How is this thing computed in the first place, right? Is it even fresh, right? And who do I talk to, right? Who was the last person who touched this data, right? All of these questions, typically is what the data catalog is trying to solve for these people, right? So you can think of it as, a search engine for data, right? For lack of a better word. But it's a lot more nuanced than that, right? Because data is not.
In my intro to you, the word social comes up. So describe white social.
Yes. So this is a very interesting insight that we discover when we talk to a lot of customers, right? When you actually go and talk to the analysts and data scientists and say, well, how do you know which table to use, which data set to use? Right? What is the very first thing that you sort of fall back to if you see a new table or new data set? And then the answer is actually always human. Right? Oh, I just look at who used this table, right? I just look at, and if I trust that person, right? If I trust that person, if that person is well known for doing good work, and then the person has used this before, chances are I will sort of trust it by social proof, right? Proximity. So that is, it might sound silly, right? Why are people not doing more scientifically and whatnot? But that's the reality that happens in the company, right? People trust people. People don't trust data. Right? People trust people who use the data or understand the data. So the social part of this is extremely important. Traditionally, the previous generation of data catalog tend to focus too much on just the technical side of the story, right? Okay, what's the scheme table, right? What's the type of a column, right? When was the last refresh? Or let me take a look at the lineage and do all that. That's all great and good. Those are very, very important signal, right? But it's not complete. Right? People need to know more to that than whatever you can collect it from various systems. Right? People need to know, if I'm doing use case XYZ, how do I filter this particular column based on what value and all that. And that sort of nuance, you cannot get it from the system itself, right? You have to basically get people involved in order to extract those information. And this is sort of linking to your knowledge base, your knowledge graph.
So you also use the word search. So I imagine if I'm in the Metaphor product, I go, I need sales data for the East Coast. I type that in. And so what do I get in response? And how does the social aspect manifest itself in the response?
Excellent question, right? So traditionally, data catalog works as like Google essentially, right? It's sort of the keyword-based approach. You type in certain keywords and hoping you have enough keywords hit that the return result makes sense. Right? Obviously, with Gen AI and large language model and RAG and all these things come into play, search are quickly being replaced by these sort of, almost like a question and answer sort of in natural language, right? And then it doesn't even just limit it to just like a web page, right? It's extending into Slack, it's extending into Teams, right? Where people already chatting, with other people, asking questions and whatnot. And you can imagine, a bot, basically they're chatting with a bot, or the bot just join the conversation and say, oh, I see you asking, sales data on the East Coast. You know what? Here's a table that matches that, right? And in terms of the social part of it, right? That is kind of the tribal knowledge of it. So we will surface up things like, okay, if you look at this table has been queried by all these other people in the past, right? So once again, coming back to the same example, oh, if I see this rock star in my team that's querying this table, it probably is a good table to query, right? And then you can even look at what they did, right? Exactly. Okay, what kind of query did they issue, right? And then you can say, oh, okay, maybe that is the use case I want to see. And of course, with Gen AI, once again, you can now translate all these complicated SQL query into something that is very, very human digestible. And then you can even just by looking at those, you can say, oh, this is indeed the East Coast sales data that I was looking for, or no, this is something else.
All right. So describe what graph you're building, how you build it, and why is it useful?
So there are multiple layer of graph that you can think of, right? So at the sort of the technical level, lineage itself is essentially a graph.
Mm-hmm.
This table come from that table, come from that, right? This column came from those two column combined, whatever, right? That itself is already naturally a graph that you can understand. And we generally call these are technical graphs, right? So they're very basic, very technical related, and you can easily derive those without a whole lot of effort as well.
So those you can automatically build.
Yeah, so we invest a lot on SQL parsing, right? And we do believe we have the industry leading SQL parser, right? And not just SQL parser, right? I mean, because you want to look at data beyond your data warehouse, right? You want to look at how the data is being used in the BI world, right? Popular cases is like Power BI, Tableau, and all these BI systems that basically fetch from the warehouse in order to populate graph. You want to have that lineage as well. So it requires parsing more than just pure SQL, right? In the case of Power BI, it has its own language called Power Query, which is a very weird language, right? But then inside can be another SQL embedded inside the Power Query, and it goes crazy, right? And then Tableau also has its own flavor.
This technical graph is built using the schema and also the queries that people are running. Okay, so then
that's correct. Yeah, so we're basically taking all the query log from Snowflake, BigQuery, Databricks, and then we basically parse it out and then build up this entire graph.
And then what's the next graph?
So the next graph is if you want to go one level up, knowing yes, these tables are related, these tables are derived from that is great and good, but from a business perspective, people want to know what does that mean, right? What is the business thing around it, business entity around it? And some people call that semantic layer, right? Some people call that semantic graph. But that's basically, think of it as a condensed version of the lineage graph, but represented in a way that is more business friendly, right? So now instead of seeing, customer underscore table underscore, raw get transformed into customer underscore table underscore, refine, right? You see customer as an entity in the graph, right? Because that's what you care about. That's customer, right? You can see, yes, we get the customer data, and then we use the customer data joined with, their session activity data on our website to produce the next thing. And that's the next level. You can call that a business graph, semantic layer, but that's kind of the next level.
So it's almost like the same graph, but kind of translated in business language.
And you can think of it as two steps. One is you're trying to do clustering, right? You basically cluster similar stuff together, so you don't end up with this monstrous graph, right? That's one step. And then the other step is you want to bring in the business meaning of these things, right? Which is quite difficult because every company has a different way of approaching this, right? And different definitions on things.
And
so
this,
you have to be able to marry that into this.
so both graphs are built automatically.
That's correct. Yeah. So you build a semantic graph automatically based on the lineage graph. And you know, I want to put a caveat out there, right? This is not like, you know, it's not, you know, all done and what, right? This is still an active area of research, even for us as well, because it is a very difficult problem, right? And I don't think anyone in the industry have claimed that they have solved this problem at this point. But we think we have a pretty good shot at it. You know, like you said, by marrying the actual business definition, business data, along with the raw lineage at a column level, to form this particular business layer. And I think AI has a big role to play here, because a lot of time, you know, as a human, you can look at this and say, oh, of course, this is customer data, right? But for machine to do that, it's much harder. But AI can definitely sort of fill in that gap and say, let me try to understand your industry, understand the typical practice involved, and then understand how things are typically arranged, and then look at that and try to come up with a semantic graph for you.
You know, you should talk to the people at Sensing. Paco is now there, because you can use their tool to resolve entities. So in other words,
yes,
know,
entity resolution, yeah.
Yeah, if it's the same customer, really, you know, so you can resolve it so your graph is cleaner. All right, so then is there another graph, or can we talk about why this graph is useful? Why these graphs are useful?
There's actually a third layer, which is you know, which is in the social part that we talked about just now, right? So this is the social graph, right? If you think about it, you know, in company you have teams, right? And then these teams are generally not like hard and fast, right? It's not like it's clearly defined. It's generally sort of roll up to the same manager, but not always the case, right? People, you know, multiple people on the multiple manager come and work together, work on the team. So the team concept is very fluid, right? And then, of course, people is probably more well-defined. If you have the directory, you have the people data, right, so to speak. And then now, you want to build up this team graph, right? And then team, you can also extend it into something bigger, for example, business unit, right? For example, and then eventually the whole company.
So is this just based on what's in the HR?
That's correct. You use the directory to get.
It's not some kind of magic thing where, okay, I'm going to look at how Mars uses tables and I'm going to impute that he works for Ben or is in the same team as Ben. Nothing like that. You just look at kind of the org chart.
No. So sorry. So let me clarify it, right?
Yeah.
The people information obviously comes from the HR system or the directory, right?
Yeah.
The grouping of the people, that is itself, like I said, it's not a clear-cut thing, right?
Yeah.
Your org chart is not going to tell you that. It will tell you some part of it, but it will not tell you the whole story, right? So to derive these sort of relationship of people sort of work on the same project, or people who, you know, they look at all these dashboards all day long, right? These are information you gotta sort of get it from the system themselves. Once again, query log helps a lot, right? By looking at that, you know who queried something in the past and whatnot. So you can use that to cluster people together,
so
right?
Essentially, you have two data sources, which is basically what the org chart tells you, and then how they actually use data.
Their activity, right? So activity including query log and what they do in the BI tools, right? So once you marry those two together, then you can produce a social graph, right? And then you might ask, oh, so what's the big deal, right? Knowing social graph, so what, right? There's a lot of interesting things you can do once you have the social graph. First of all, if you look at, you know, the buzz, you know, the last year's buzzword, I guess, right? Data product, data domains, and all these things, right? When people talk about data mesh, right? All of these things, what are they really talking about? If you really double click into it, you realize they're talking about some sort of social graph, right? Because that's how things are naturally organized in the company. If you want to say, oh, I have a data domain, right? What is the domain? Domain is really a group of people who work on things that are closely related to each other, right? So if you have this social graph, you can actually derive a lot of these things, right? And then even sort of continuously modify, right? And then you can also surface up a lot of useful insight to the user, right? For example, think of it as the Amazon, you know, people who bought this also buy that. sort of suggestion, right? Then you can basically surface up a lot of things based on your social context.
So then all three graphs are kind of built automatically, kind of.
Mhm.
And
Yeah.
then in the course of using metaphor, you are actually using all these graphs to serve the user's needs, right? So
That's correct. Yeah. Mhm.
if I ask you, Mars, what would metaphor be if you didn't have these graphs? Would it be materially different? So in other words, how impactful are these graphs to what you can deliver?
So first of all, I think one thing we want to make clear as well is we don't surface these graphs raw to the user.
Of course, yeah, yeah.
Surfacing them raw is not useful.
No,
You want to build
but basically
features
it impacts what you show what the results you show the user. So I guess
Yeah.
my question is, if these graphs didn't exist, what would would you say that metaphor would be not as good?
we will be Informatica. We will be, sorry, no offense to anyone who was on Informatica, but literally that's the old state, right? Which is they had Informatica had a graph, which is just a technical graph, right?
Right.
Just a lineation. That's pretty much it. There's not a lot of business related stuff. There's not a lot of social related stuff on it. Yeah. But in our opinion, all three graphs are important. And when you bring all three of them together, that's where magic happens. And of course, you sprinkle enough AI on top of it, it becomes, a unicorn or something like that.
So the question for you is, so how big can these graphs get?
It can get pretty big and pretty scary. Some of our customers that we work with, right? They literally have millions of tables.
Yeah.
And if you multiply that by the average number of columns in there, that's how many columns you have, right? And then think about every column being a node potentially in a graph. And then potentially you can have, every column linking to every column. Obviously that doesn't happen in real life, right? But that's a lot of connection, a lot of nodes and a lot of edges. Right? That's the column level lineage graph alone is pretty scary. And then of course on top of it, the business stuff is obviously a lot more confined, right? I mean, because you need to be able to somewhat fit that into, your company's collective wisdom, so to speak. Right? So there's limit there. The people graph, once again, it's a little bit bigger actually. If you think about it, because people can do a lot of actions, right? And then they do actions all day long, right? This person query that, this person look at that dashboard, this person, updated the definition of the table, right? There's a lot of interaction that people can do. And then once you multiply that by the 1,000 users in the company, 10,000 users in the company, how many data users you have in the company, it can get pretty scary very quickly as well.
So then, if I type a query into Metaphor again, I want to get sales data in the East Coast. At some point, you translate that into a query that you can query these graphs, right? So then the question is, are you using a graph database? Are you using Cipher or?
We are in the nascent state of using a graph database, so to speak, and we are not using Neo4j.
I have a suggestion.
But we are using.
I have a suggestion for you. Open source.
Yes.
Kuzu. Kuzu DB.
Okay, that's a good one. We have not come across that. We'll take a look at it. But we are using OpenCipher as the language for the graph itself.
So Kuzu speaks Cipher. It's single node. It's like, think of it as like DuckDB for graphs. It scales to.
Yeah, there's also a main graph or something.
Scales to large graph.
It's not a project there.
Yeah. So anyway, so
we're currently using AWS Neptune because it's just the easiest thing to start with. But as our scale grows, I imagine we will probably start hosting this ourselves rather than using a pure managed solution.
Yeah.
Still early days, like I said.
So with that, thank you, Mar. So we had two topics here: open source security and graphs. The implications of graphs for data discovery.